Welcome back to another statics video, and we're in chapter 6 in the textbook talking about friction. And in the previous video we had solved this example problem 6.8 where we looked at a rope being wrapped around a static drum and calculated the amount of force required to keep a 981 Newton weight suspended in the air. There's just one more thing I want to touch on here with belt friction, and it really has more to do with algebra than anything else. So in this example problem, we knew the large tension, we knew the coefficient of friction, we knew the angle of wrap. E is a constant, so we had to solve for Ts. What I want to throw in here, and this is not in the textbook example, just a little additional thing I want to make sure we talk about, is what if the unknown variable is in the exponent here? What if, for instance, we need to know the angle of wrap? So I'm going to use the same values from this example 8b. I'm just going to write down up here that the TS, the small tension, was 58.0 newtons. And then I'm going to pretend that we don't know what the beta is, that's our unknown that we're trying to solve for. So let me erase this stuff here. So there we go. So again, let's pretend that we don't know what the angle of wrap is. Maybe the angle, or the question was saying, we have this 981 Newton weight. We want to keep it suspended. We are capable of pulling with a force of 58 newtons. How many times do we have to wrap that rope around the drum in order for us to be able to do that? So let's just say that beta is now the variable that we have to solve for. So we would know that the large tension is 981. We would know that the small tension is 58.0, and then this would be e to the power of, we would still know that the coefficient of friction is 0.3, but we wouldn't know beta. How do we solve for that? Well, the first thing we would do is divide both sides by 58. So I've got 981 divided by 58.0 is going to be equal to e to the power of 0.3 times beta. But then what? We've got our unknown variable up here in the exponent. How do we isolate it? How do we solve for it? And so what you end up doing is you take the natural log of both sides of the equation. ln of 981 over 58 equals the natural log of e to the power of 0.3 beta. So I'm just taking the natural log of both sides of the equation. And I mentioned earlier in the previous video that this e to the power of, this exponential function, is the inverse function of a natural log. The two of them cancel each other out. They're like addition and subtraction, or multiplication and division, or squaring something versus the square root. They're just going to cancel each other out. And so then what we're left with is the natural log of 981 over 58 is going to be equal to, these things cancel out, and all I'm left with on the right side is 0.3 beta. So finally, to get beta by itself, I would just have beta is equal to the natural log of 981 divided by 58.0, and then divide all that by 0.3. So let's plug that into our calculator and see what we get. That gave me about 9.43. Now this is in radians. Radians are often expressed in terms of pi. So what I would probably want to do is take this answer here, and instead of just expressing it as 9.43 radians, find out how many pi that is. If I take my 9.43 and I divide it by pi, that gives me 3.00 pi, which we already knew was the angle of wrap. But oftentimes, if you are going to be asked for the angle of wrap, radians, although it's useful mathematically, is not a very practical unit for measuring angles. Engineers, if they're going to actually be building some sort of a machine and they want to measure the angle of something, they usually use degrees. Protractors are based on degrees, not radians. So what we would probably want to do in reality, if we were solving for the angle of wrap, is take that 9.43 radians and convert it into degrees. For every pi radians, that's 180 degrees. So if I take that 9.43 and I multiply it by 180 over pi, the radians will cancel out and I'll be left with degrees. And so that should equal 540 degrees. So that is a more practical unit to express your answer in, and we can see that that is actually what the original problem gave us. 1.5 full rotations is 540 degrees, or 3 pi, or 9.43 radians. So the main thing I wanted to point out here in this video is how to get rid of e out of the equation if you're trying to solve for a variable that is in the exponent. You need to take the natural log of e, of the e exponential expression, and that will cancel it out. Take the natural log of the other side of the equation, and that's how you solve that. I know logs and exponential functions are things that I don't use very often, and math is something I've always said, if you don't use it, you lose it. So just as a reminder, if it's been a while for you as well, since you've worked with logarithms or exponential functions, that's how you do it. All right, I'm going to finish here. I just wanted to make that this video to specifically address that issue, the algebraic issue of E. And we've got one more topic to discuss in Chapter 6, and that'll be coming up in the next and hopefully final video.